All right, so in this video, we're going to do dimensional analysis. This is kind of a good stepping stone between the data analysis module 3 and the probability in module 4. So I'm going to share the whiteboard. So dimensional analysis is something you would have seen back in chemistry or maybe physics. We'll do it a little bit differently here since it's to relate more towards a business. But anyway, so in the notes of module 4.1 probability on the first page, the example is a real estate developer. So again, right now we're going to be talking about dimensional analysis. So dimensional analysis. All right, so in the example, we have a real estate developer asking, how do we improve revenue? Of course, the simple answer would be to just sell more property, but how do you do that, and where does the revenue come from? So first, we have to break down the revenue. So we'll say the revenue is going to be equal to the average price per property. So the average price per property multiplied by the number of properties sold in that given time frame. So this is a year, then that would be the number of properties sold in that 12-month period. So again, we're asking, how do we improve revenue? Where do people buy the property come from? Where do they come from? How do they find out about the property? They find out about the property from maybe advertising. So maybe we want to know, how many more people do we need to advertise to in order to sell one more piece of property or one more lot in the subdivision or one more condo in the complex, whatever it is. So let's say we want to look at properties sold. Property sold per, let's say, ad view. We want to know how many more people do we need to advertise to in order to sell that one more piece of property. So let's break it down. Let's say for every one piece of property that we sell, so for one piece of property, let's say on average, you have to meet with someone 4 times. So you have to meet with this prospective client, or you have to meet with this respective client 4 times on average in order for them to make a commitment on a piece of property. Let's say for every one person that you meet with, so let's say for every one meeting, you get 4 phone calls, 4 phone calls of people you have to talk to, or 4 phone calls in the office. Let's say for every one phone call you get, let's say on average, 20 people look at the website. Let's say for every one person that looks at the website, in the notes we have 20 ad views. And in this, you see that it cancels out. So it's just like we did in chemistry. The web views cancel out with the web views. And the phone calls cancel out with the phone calls. And the meetings cancel out with the meetings. And we're left with one property per 4 times 4 times 20 times 20, 6,400. So now we're left with, for every one property, you have to advertise on average 6,400 people, or 6,400 ad views, just in order to get that one more property sold. So let's say if you have to break even, or if just to break even in the company, we'll say, let me move my pad here. All right, so let's say right now, like here, let's say the x-axis is the advertising views. Say our y-axis is property sold, or I'll do an S. for sales. Let's say you advertise to nobody, then maybe you don't sell anything. Let's assume it's a straight line for now. So let's say if you want to, I'm going to change this to N. Go up here. Instead of S, I'll say N. So the number, let's just do the number of properties sold. If you want to get 10, based on the math that we just did, if you want 10 properties sold in that given year, you'd have to advertise to not 6,400. You have to advertise to 64,000 people. This is assuming that it's linear throughout everything. But if you're specific to a geographical location, if you're specific to say Virginia Beach or Colorado or wherever it is, or maybe you're an e-commerce company and you sell specifically to a very specific subset of the population, the amount of people that you can advertise to can only be so many, and eventually you're just going to kind of taper off. And there's only so many people that you can advertise to, so it's not linear throughout the entire thing. But of course, at least it's linear throughout some of it. But anyway, so for this, the reason why I want to talk about this before we started probability and after data analysis is each one of these things. So let's say a phone call per website view. This right here, this is an example of a random variable. Random variable. All of these are examples of random variables. So this is why we're talking about it now instead of earlier in the class or after data analysis, after you get comfortable with manipulating the data frames and all of that. So all of these are random variables. So even though they're random, and even the parameters themselves are random, we can break it down through dimensional analysis and see the different pieces of this. What are the different pieces of getting that one more property sold? Or what are all the pieces involved in order to sell that new vehicle or whatever it is that you're trying to sell? In order to get more revenue, you have to, if we break it down into steps, each of these can be represented by a random variable. So this is, again, breaking it up like this and all the dimensions. This is called dimensional analysis. And this is, now we'll be able to start probability. Again, this is module 4.1, probability. I'm going to finish this video for now, and then we'll start probability in the next video.